thing about this right here is that you always have to go from left to right. If you don't go from left to right, you will answer the correct question incorrectly. So you can think of your function as like a roller coaster, right? And so if your height is either increasing, you're going up, or it's decreasing, you're going down. Here you increase again, decrease again, right? You always want to start on the left-hand side, because if you start over here, you'll be going backwards and you'll get it wrong. So if we look at this graph right here, in this first part, are we increasing or decreasing? All right, then here we switch to decreasing, and right here, increasing again. All right, so that's what we're looking at. Most kids can usually answer that pretty easily whenever I point to the parts. What's difficult is writing down the intervals where that happens. So let's do a couple problems here. All right, so here we have just a pretty basic parabola that we're looking at. So if we start on the left-hand side and highlight our graph, are we increasing or decreasing here? Decreasing. And we decrease until we get right there at the very bottom of the hill, and we stop decreasing, right? So whenever we're telling where we're increasing or decreasing, we're giving the domain where that happens. And for domain, do we look at the x-axis or the y-axis? X-axis, right? So this does not have an arrow on the end of it, but this function. I'm pulling these graphs from Desmos. It doesn't put arrows on the end, but there would be arrows there. So we are decreasing. Now, we're thinking about domain. So if we're thinking about the domain where we're decreasing, over here, are we decreasing over here? We are, because this keeps on going, right? And I know when I do that, it makes you think, well, it's going up, so it's not decreasing, but we're going left to right. So it's way high up here, and then it's coming back down over here, right? So it's still decreasing even way over here. So we're going to go negative infinity up to this point is where we stop decreasing. What is my x value there? 0. So negative infinity to 0. There is actually a lot of debate in the calculus community about whether or not you should use a bracket or parentheses for this. To avoid a long explanation on that, I will just say that most textbooks now will use a bracket because that last point is lower than the point before it. My calculus teacher taught me to use a parentheses, and some textbooks do still do that. But just, I will tell you this, on the AP Calculus exam, and you guys may think I'm in the wrong class, but this overlaps on both things, just at a calculus level. They don't count off if you use the wrong thing right there. I'm going to do the same. Like if you accidentally use a parentheses where it should be a bracket for the increasing, decreasing, I'm not going to count off for that because there's some debate on it. So we're going to use the bracket. So then at that point we're going to switch to increasing, and it will increase for the rest of the time. So at this point we're talking about domain right here. We got 0 over to where? Infinity over here. So we are increasing from 0 to infinity. Okay, questions? All right. Let's look at our next graph. Okay, for this one, if we start over here on the left, right, on the left side, for this first part, what are we doing? Increasing or decreasing? Increasing all the way up to right here. Okay, so if we want to talk about that section, okay, there's not arrows on the end of this, but there should be. Are we increasing way over here? We are, because it would be way down here. We'd be going up, 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 till we get to here. So negative infinity to where? almost, what kind of 4? Negative 4. So we'll have negative infinity up to negative 4. It's negative 4 right here, because you're looking at the x-axis right here, so you'll have negative 4 right there. And then let's just skip over to the other increasing part. So that other increasing part's over here. And so where does that second increasing part begin? 2 up to infinity. When you say negative 2, you're looking at the wrong thing, because the only time you're going to look at the y-axis is for range. So if it asks increasing, decreasing, positive, negative, any of those things, we're looking at the x-axis. So we want to do 2 up to infinity there. And so this piece in between right here is where we're decreasing. That's this section right here. And that is in between these two that we have here. So that would be from negative 4 to positive 2. Okay, questions? All right. We about ran out of time for these notes in first period, so I'm going to skip this right here. We were going to type it into Desmos, but we're going to get some more practice, so I'm going to skip this one. Here, I told you I might do things like that sometimes. All right, so one thing we have to be able to do is we have to be able to look not only at graphs, but also at tables. So we're going to go look at this table. First of all, whenever I answer this question, a table never gives you 100% exactly the answer, because this table gives me the number 0, 1, 2, 3, 4. Are there any numbers between 0 and 1? There are no whole numbers between 0 and 1. Are there any numbers between 0 and 1? Yeah, there's like 0.5 and 0.6 and 0.7 and 0.802. There's a lot of numbers. In fact, there's infinite numbers between 0 and 1, right? So a table doesn't give us all of the numbers. So we can't know everything that's happening here. For all we know, between 0 and 1, maybe at 0.5, this might go to 100 million. We don't know, right? So a table can never give you the exact answer, because it's only giving you pieces of what you know. So rather than saying this is definitely where we're increasing or decreasing, I'm going to write possibly. And then we're going to look at what's happening here, right, to tell where it's increasing or decreasing. Because we can give an answer that would be consistent with our table, but it might not be right. But we can still make some inferences from this table, right? We can make some assumptions of what might happen. So first thing you want to do is make sure that your x values are going from left to right. If these were backwards, if they were 4, 1, 2, 3, or 4, 3, 2, 1, then we would have to sort of reorder our table. But they are going left to right, 0, 1, 2, 3, 4. So this is going left to right, so we're good. We want to be looking at these left to right. From negative 1 down to negative 2, increasing or decreasing? Decreasing. Right? What about from negative 2 to negative 3? Decreasing. What about from negative 3 to 2? That is increasing. And from 2 to 6? Increasing. So we don't know for sure that it switches at x equals 2, but it could switch at x equals 2, right? It might switch at 2.1, but it switches somewhere around there for sure. So we would say that possibly what is happening here is that we are decreasing, and we want to use our x values, not the y values. So decreasing from 0 to 2. and then we could be increasing from 2 to 4. And I'm pulling those numbers here. This is decreasing. This is increasing. We use those numbers in the x coordinates, just like we look at the x-axis. We don't use the y numbers over here. Okay, questions? Since they are negative here, these numbers are in. Okay, so let's write this. Function is decreasing. So the x values are increasing, but the function is increasing or decreasing here. So you are correct. These are all increasing, but we're looking at whether or not we're like decreasing over here, and that tells us that the function is decreasing from 0 to 2. And then we're looking over here to see if these numbers are the f of x is increasing or decreasing. That tells us if the function is increasing from 2 to 4. Okay, questions so far? All right, we got a bunch more we have to learn to do here. Okay, positive and negative is different than increasing or decreasing. Students get them mixed up a lot. But for positive, a function is positive when its y value is positive. And a function is negative when its y value is negative. So I'm just going to draw in some sort of function here. Yeah, as close as you can here. So if I think about points on this graph, right? If I'm looking for points where my y coordinate is positive, right? Like just think of maybe like this point right here. This is the point 2, 2. Y coordinate is positive, right? So the graph is positive there. If I pick this point right here, I didn't, I just drew something in here. This is not great. This is the point 8, negative 4. Y coordinate is negative there. So the graph is negative there. So what we can do to tell for this is, obviously we don't want to look at every single point. We want to look at the dividing line between positive and negative, and that's the x-axis, right? So if we look at that x-axis right here, anything that is above the x-axis is going to have a positive y coordinate. Anything below the x-axis is going to have a negative y coordinate. So a function is positive when it lies above the x-axis, and a function is negative when it lies below the x-axis. So we're not going to go into actually doing this problem. I just want to highlight what's happening here. So if I'm looking for the negative part of this graph, it'd be here, because that's below the x-axis, and here. That's below the x-axis. Those two pieces would be below the x-axis. So they are negative. Let me label that negative. Here and here. And then if I want the positive pieces, those are the ones above the x-axis. And so that would be this piece right here, and then this little tiny piece right here, since that has an arrow that goes on forever. That would be positive. Yeah. Yeah. Sometimes students just start getting it mixed up. Could you be positive but also decreasing at the same time? You could, right? Like this section right here is still positive,